Now, to convert binary to base 10, if we start with a value, let's say this number here, we can see that we need to add adjacent headings here and here. Now, 6432, so that's 96, so I quickly write that in for the pupils, that's 12, and then we get a 1 to add at the end and add 96 and 12, so you get 108 plus the 1, so 109 in all. Okay, so that's the way to do that conversion. However, it's just to note some little tricks or some little shortcuts that will help you, that the numbers 128 and 32 when added together come to 160. The numbers 64 and 16 when added together come to 80, and you get other ones that will help. 32 plus 8, 40, 16 and 4 give you 28, plus 2 give you 10, and so on. Okay, so those come in handy when doing the addition, and maybe then we could look at this 32 and this 8. Well, we know that's 40, plus we got the 64, so that's already made 104, and then we've got a 4 and a 1, that's 5, so we get 109 in all. I should have written a 5 in that position. So I'll put a 5 in that position, and then that comes to 109. And if I wrote it in a bolder colour, you'd be able to see a little bit clearer. But using those adjacent headings help when doing the conversion process back into base 10. The next topic to look at is hexadecimal. Now, I always look at, go back to the days of hundreds, tens and units, where we represent 723 as that value there, if I just write out 2 again. So 723 as 700, 2 tens and 3 units. Now the headings, however, have come from base 10. So if we look at units, our base to 10, 10 to the power 0, 10 to the power 1, and 10 to the power 2. And for those who were very good at maths back in primary school, they'd have done 10 to the power 3, which of course is 1,000. 10 squared is 100, that's 10, and anything to the power 0 in this area here is a 1. If I write a 1 in that position there. Then I know that the digits available are what we've got on our hands, 0, 1, 2, 3, all the way up to 9. So using those digits, I can represent any quantity, let's say of apples, pears, or anything that I'm selling in a market many, many years ago. So I can have 1 item, 2 items, 3. When I get up to 9 items, then what I decide to do is I will use this column and say there's 1 of these, and we're back down to 0 there, and we carry on counting throughout there. So that would be the base 10 counting system. There's no point teaching students that, because they know that already. So we'll go to base 16, and let's see what we need for base 16. So hex add decimal, the C in there, so DC and hexagon and a decagon, that's 6 sides and 10 sides, so that's base 16. Okay, now with base 16 we get the following headings. If we follow the same rules, just like we did with base 2, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, etc. 10 to the power 0 for base 10, or for denary, 10 to 2, 10 to 3. We're going to do the same idea with base 16, but this time using 16 to the power 0 and continuing on through that. So if I start with, let's keep getting rid of that. This board just ends up doing that sometimes. So we start off with 16 to the power 0. 16 to the power 1, and we'll also include 16 to the power 2. So 16 to the power 2, 16 squared. Now, 16 to the power 0 is 1, 16 to the power 1 is 16, 16 squared, students wouldn't take long to work this out, as 256. 256 being the number that we recognised previously as being 2 to the power 8 as well, which they'll have recognised from the binary work previously. However, which will come in handy useful when we use hexadecimal to convert binary values into hexadecimal. Digits available are 0, 1, 2, 3, all the way up to 9. But then we need representations for 10, 11, 12, all the way up to 15, or 1 less than the base itself. So 1 less than the base itself is going to be 15, so we use an A to represent 10, a B to represent 11, C for 12, D for 13, E for 14, and an F for 15. And that will have been seen on calculators previously. There's only the 6 letters are typed above certain keys in a Casio calculator. So A, B, C, D, E, F would be used to represent those values. So if I'm counting in base 16, if I get rid of some of these titles and just move the headings up a little bit. In fact, what I'll do, I'll rub those out as well and write those headings. So it's 256, although I'm not going to be counting that far in this example. So I'll start counting as we start counting 0, a 1, a 2, all the way up to 9. Then I say, right, I've now got more than 9 apples. I've got another apple, so that's now going to be A apples, then B, C, D, E, and we all go all the way up to F. So I've got a quantity of 15 apples, because I know that F is 15. And now I need to count 16 apples. Well, my base headings tell me that if I've got 16, I need to put a representation in this column. And so I'm now going to put down one of these and none of these. Now I'm going to write a subscript in there, 16, just to indicate that 1, 0, so 1, 0 in base 16 is equivalent to 16 and none of these, no ones. All right, so 16 or 116 and no units, no ones. If I then count up further, then I know that we get 1, 1, 1, 2, these would all have base. We get up to 1A. Now 1A says that there are 16 here and there's 10 ones. So that's actually equivalent to 26 in base 10. So 1A in base 16 is equivalent to 26 in base 10. Once you do this with a few times, then the students get the hang of it. So I'm going to rub out all the ones that I've got so far and throw a few more up onto screen. So if we've got that. So I'm now going to say 1, 3 in base 16. Well, that's equivalent to, that's 16 and that's 3 ones. So it's now going to be, is equivalent to 19 in base 10. If I write another number down, well, we've got 1F in base 16 is the same as, if we look at 16 plus 15 ones, so therefore that's 16 plus 15, so that gives me 31 in base 10. Carry on with some other examples, so we do 2, 4, so that's 2, 4 in base 16 is equivalent to, well, that's 2 16s plus 4 ones, so that's 32 plus 4, so that's 36 in base 10. And you just carry on going through this with a number of other students around the room who will be able to answer. So we'll start throwing in some letters now. So I'll say 3 and 3D. So this will now need a reference to the table on the right hand side over here, where we see that D is 13. So it's a little bit of calculation to find out that 3 times 16 is 48, and then plus 13, so 48 plus 13, and we get that as 61 in base 10. So 3D gives us 61 in base 10. And before you know it, they become quite comfortable. We're working with that. And then I'm going to use, I'll put that in a different colour just because I have used black over this side. So we'll now use A7 in base 16 is equivalent to what in base 10? Well, our A is a 10. So it's 10 times 16, that's 160. So I might even write that there. So 160 plus 7 times 1, so I get 167 in base 10. So A7 in base 16 is equivalent to 167 in base 10. Now there's a formal way of doing this, in that if I write out the decimal value, so if I write out 167, so if I write out 167 in base 10, and I continually divide by 16, you'll see, and put the remainder, like we did when we were converting from base 10 to base 2, continual division by 2, then if I put 16 into 167, that gives 10, remainder 7. Now I know that 10 is an A, but we'll do 16 into 10 goes 0, remainder, and it should be 10, but I'm going to use the hexadecimal system. I'm going to write the number A. So if I read from this path, we get 167 in base 10 is equivalent to 0A7 in base 16, but I'm just going to write it as A7, which is recognised as a way of writing this. I'm going to do another of these. So if we do 268 maybe or something, 278. So 268 in base 10 is equivalent to what in base 16? So put 16 into this, and we know that 16 goes in 16 times. It actually goes in let's divide that. So 16 goes into 256, I know 16 times. So it's 16 times, remainder 12. Right? Now I know that 12 is the letter C. So if I write C here, and 16 goes into 16, once, remainder 0, and 16 goes into 1, 0, remainder 1. And if we read that as a value from the bottom to the top, we get that 268 in base 10 is equivalent to 10C in base 16. 1 is 256 and the C we know is 12, and so it adds those up. So quite a complex one, but just by knowing that 16 times 16 is 256 works out fine. So there's lots of those you can throw in as examples for the students.